we're going to look at drawing ray diagrams for diverging lenses, also called concave lenses. So, rules for drawing ray diagrams. Ray diagrams are just images that we form or pictures that we draw to figure out where images will be located based on what kind of lens or mirror we have. We draw light as a straight line and then see where those lines converge or don't. So these rules are not written in your notes, so if you need to write them down, please make sure you do. If you looked at the convex lenses, then you already have these rules. Rule 1, draw a line from the top of the object parallel to the lens. Refraction or bending is through the focal point. Step 2, draw a line from the top of the object through the center of the lens. And step 3, where the lines converge or come together, is the image location. And you always draw your images from the principal axis to the point of crossing. So all ray diagrams for diverging lenses will be done just like this and give you exactly the same type of image. So step 1, draw a line from the top of the object parallel to the lens. The refraction or bending is through the focal point. Now, because the focal point is on the virtual side, not the real side, we're going to use a dotted line. So the reason why this side is real is because light goes through a lens, not bounces off. So we're going to change it to a dotted line. Dotted lines represent virtual. And for completion's sake, draw this going out, diverging away. Step 2 is to draw it from the top of the arrow through the center of the lens. And you see, we have a crossing point. This is where our image is located. We draw it from the principal axis up to the point of crossing. So this image and all images by this lens are virtual, upright, pointing up, and reduced or smaller. Now some uses for different types of lenses. So this is for both types of lenses. One is a camera. So a camera works because you've got a lens, and as the lens is moved closer and further from the subject, you can focus it by making a larger or a smaller image. Telescopes and microscopes work the same way, where again, I know these look really complicated, but the idea is you have light going through the lenses, creating larger images. So now let's talk about the eye. So again, if you're looking at the notes, then you can just fill in the blanks as I'm saying them. The eye contains a converging lens, which produces a real image on your retina. The only reason you see things right side up is because your brain adjusts it. So it's all those electrical signals, your brain takes them and then makes them flipped upside down, basically. So you're looking at everything upside down. You can focus on objects by using muscles to change the thickness of your lens. And so you can see some muscles here and here that stretch and compress your lens. To see objects far away, you relax, and to see objects close up, you contract. But the way that we use other lenses, so external lenses, is in vision correction. So if you have hyperopia, that means you are farsighted. So farsighted, your eye is too short and everything is focusing beyond your eye. It's far from your eye, farsighted. To fix this problem, you have to put a convex lens, a converging lens, which makes it go shorter so it gets to the edge. For myopia, which is nearsighted, which majority of people are, now it's converging before your eye. So usually because your eye is slightly longer. And so you have to get a diverging lens in order to get it to reach.